Hello everybody. This tutorial is going to cover scientific notation skills. This is a math skill that you need in physics in order to work problems, because a lot of numbers that we work with or measurements that we work with in physics are extremely large or extremely small. So scientific notation is a skill that you must be able to use. When we're doing the physics, it's a lot easier to learn the physics if you're not struggling with the math. So we need to make sure that you are adept at doing scientific notation. So in scientific notation, the proper form for scientific notation is that there can only be one digit to the left of the decimal place. In other words, when you write a number in scientific notation, it's going to be digit, decimal, digit, digit. There could be more digits after the decimal, but usually we just show the 2 right there. Times 10 to some power, n. Okay? So digit, decimal, digit, digit. Only one digit to the left of the decimal. Now, the two parts of a number that is in scientific notation. You have the coefficient. This is the numerical value of the measurement. And then you have the magnitude. The magnitude tells you where along the decimal line that the coefficient is located. For example, 10 to the 6th, that's a million. So the 7 belongs in the millions place. That would be 7.9 million, whatever the measurement is. Okay, so coefficient, magnitude. Now, to convert numbers into scientific notation form, okay? And these could be very small numbers or very large numbers, and we're going to start with the large numbers, values that are larger than 10. Now, the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, you don't have to worry about because, well, they're only one digit anyway. But 10 or greater, in order to get the decimal behind the first digit, you have to move the decimal to the left. For example, if you have 6,810, the decimal would be located right there. Also, any number that is not in scientific notation form has an understood times 10 to the 0 power. If you remember from math class, 10 to the 0 is simply 1, and any number times 1 is itself. Okay, but knowing that there's an understood times 10 to the 0 there is rather important, as you will see. Now, in order to convert this into proper scientific notation form, we need to take the decimal and move it until it's behind the 6. So we need to move it 1, 2, 3 places to the left. If you're going to move the decimal 3 places to the left, you're going to add the number 3 to the existing power of 10, which in this case happens to be the understood 0. So you'll get 0 plus 3, or 10 cubed. So the value 6,810 is therefore 6.81 times 10 cubed. Okay? Now, look at all of these little examples here. Let's go through these rather quickly. So we have 1,230,000. And if I write it like I did up here, that would be 1,230,000 times 10 to the 0. All right, then what we're going to do is we're going to move the decimal. Oops, I left a 0 out, didn't I? We'll squish it in right there. We're going to move the decimal 1, 2, 3, 4, 5, 6 places to get it behind the 1. So we end up with 1.23. Now these zeros are not significant zeros, so they can be dropped. In other words, they're placeholders. They're not measuring. So we get 1.23 times 10. Now we move the decimal 6 places to the left, so we're going to add a 6 to the 0. 0 and 6 is 6. So 1.23 times 10 to the 6. Okay? 56,000. We're going to move the decimal 4 places to the left. So we'll end up with 5.6, all right? And then, remember, normally we have an understood 0 right there. But because we moved the decimal 4 places to the left, we're going to add 4 to that 0, and 0 plus 4 is 4. The next one, which is a biggie. I don't know why I made it so big, but I did. All right? We've got 3, 6, 9, 10, 11 places to move the decimal from here all the way over to there. Okay? So we're going to end up with 9.13 once the decimal is moved. Oops, I forgot the 6. Once the decimal is moved, times 10 to the 0 plus 11, or 11. All right? 356.5 would become, move it 2 places, you get 3.565. Never drop your significant digits. And that's going to be times 10 to the 0 plus 1, 2. Okay? Now, the last two are interesting. Notice that they are already in scientific notation form. However, it is not proper form because there's 3 digits in front of the decimal here, and there's 4 in front of the decimal here. We can only have 1 digit to the left of the decimal. So to put it in proper form, we have to move it. So on this one, we would get 6, 2 places to the left, 0.251, times 10. Now this case, we don't have an understood times 10 to the 0. We have a 10 cubed. We moved it 2 places to the left, so 3 plus 2 places is 5. So you get 6.251 times 10 to the 5th. Okay? The last one, notice we have a 10 to the negative 8. So here we're going to move the decimal 3 places to the left. We get 8.3. And for the power of 10, we're going to say negative 8 plus the 3 places. That would be negative 5. Okay? So, converting very large numbers into proper scientific notation form, you would have to move the decimal left. And anytime you move the decimal left, you add to the power of 10. So left, add, they go together, okay? Now, what if the values are very tiny? What if they're decimal values? Very tiny fractions. Well, values that are smaller than 1.0, then the decimal would have to be moved to the right to get it behind the first digit. All right, for example, 0.00681. In order to put it in proper scientific notation, we would need to move the decimal 1, 2, 3 places to the right to get it behind the first digit. What do we do with our understood power of 0? Well, when you move the decimal to the right, you're going to subtract from that. So 0 minus 3 would be 10 to the negative 3. So the answer for that one would be 6.81 times 10 to the negative 3. The point is, if you need to move the decimal to the right to put it behind the first digit, then you're going to be subtracting from the power of 10. So, right, subtract. Look at these examples. On the first one, we're going to need to move the decimal 1, 2, 3, 4, 5, 6 places to get it behind the floor. So we get 4.6, and because we have an understood times 10 to the 0, so we're going to say 6 places, 0 minus 6 is going to give us negative 6. Okay? Look at the next one. We're going to need to move the decimal 2 places to the left, and then we're going to subtract 2 from the understood 0 on the 10, so that would be negative 2. All right? Over here, we're going to need to move the decimal 1, 2, 3, 4 places, and then we're going to subtract that 4 from the understood power of 0. Okay, and then we have this really teeny tiny one. And I should have split those zeros up a little better. Let's see if I can do that real quick so we can just tell. All right, so 3, 6, 9, 12 places. We need to go 12 places to get behind the 9. So we're going to end up with 9.74. And then on the understood 0 on the 10, we're going to subtract 12. So you get 9.74 times 10 to the negative 12. Not too bad, is it? Now, again, look at this last two. They're already in scientific notation form. It's just not proper form. There's more than one digit to the left of the decimal. So we need to move the decimal. And in this case, to the right. But when we subtract, we're not subtracting from an understood 0. We're subtracting from the power that's already there. So move the decimal 2 places to the right. And we're going to say 6 minus the 2 places. That gives us a power of 4. So 3.35 times 10 to the 4th power. On this side, we need to only move the decimal 1 place to get it behind the 4. So now we're going to subtract that 1 place from the negative 3 power. Negative 3 minus 1 is negative 4. So you get 4.74 times 10 to the negative 4. Now, on the practice sheet, you have some where you're going to practice very large numbers, moving the decimal to the left and adding to the power of 10. And you're going to have some very small numbers where you move the decimal to the right and subtract from the power of 10. Now, left add, right subtract. What's a good way to remember what you do? Well, left and add go together because they're the small words. Right and subtract go together because they're the 2 larger words, if that helps you remember. Left add, right subtract. Okay? Now, sometimes when we're using scientific notation in calculations, we have to put it into our calculator. In other words, there are some times when the numbers are so big or so small that they will not fit on your calculator screen unless you have a graphing calculator. But even then, it's still a pain to put in all these digits. So, using scientific notation on the calculator is extremely important. Let's talk about that. And that's the second page here. Now, I'm going to show you real quick several calculators, several makes. Now, how you do scientific notation is going to depend on your scientific calculator. All right? So I'm going to show you first a very common graphing calculator. And if I turn it on, here we go. Now, if I have a number that I want to put in scientific notation, what button am I going to use for that? Well, on a graphing calculator, it's denoted with a double E. And in the particular model that I have here, it's the second function of this button right here. So if I was going to use scientific notation, as I was putting the number in, I would have to hit the second function and the E in order to use it. In fact, when you do that, an E comes up. But you don't do that until you're ready to put in the power of 10. So let me show you what that would look like. Look at this number right here, 6.81 times 10 to the negative 3. I'm going to put that in here, so just watch what happens when I do that. I'm going to put in the coefficient first, 6.81. So there's the coefficient. Now I need the calculator to know that this is a number and I'm not finished writing it in yet because it has a power of 10. It's in scientific notation. So I'm going to hit second E. That's the same as saying times 10. And now it's prompting you for the power. So in this case, the power is negative 3. So I'm going to hit my change sign button and then the 3. Whoops, how did those arrows get in there? I must have hit something. Hang on, guys. There we go. All right, so when it looks like this, I hope y'all can see. Oh, there, now you can see it. All right, so that says 6.81 times 10 negative 3. Okay, the E means times 10. And we're not talking about the little e for exponential functions. We're not talking about this. That's inverse natural log. That's something altogether different. You have to look for the capital E's. Okay, that's scientific notation. All right? Now, here's another example of a calculator that has scientific notation, but strangely enough, instead of a capital E, it uses EXP. So for the same number, I want to put that into the calculator in scientific notation. So I say 6.81. You always put the coefficient in first and then tell the calculator it's scientific notation. So now, scientific notation, 2 zeros come up. Those are the zeros for the decimal place. Not decimal, those are the zeros for the power of 10. You can have anywhere from 1 to 99 power. So we're going to put in change sign 3. So that's 6.81 times 10 to the negative third power. Okay? And then you can add, subtract, multiply, or divide. All right? The last calculator is this one. This is a common calculator. It also has the double E like the graphing, okay? It's also the second function of this particular button. So I would stick it into the calculator. Okay, so 6.81, and then I'm going to go second, hit that button to get the E. Now the calculator knows it's times 10 and it's asking me for the power. So I hit change sign 3 and I get 6.81 times 10 to the negative third power. Now, I know that a lot of you are used to using the caret. All right, let me show you what I'm talking about. A lot of you are used to doing this, 6.81 times 10 caret negative 3, okay? Now, yes, that is 6.81 times 10 to the negative 3, but the calculator does not see it as one individual measurement. It sees it as two measurements, 6.81, and 10 to the negative third power that are being multiplied. It doesn't see it as one measurement. So when you are calculating and adding and subtracting and multiplying and dividing with other numbers, your order of operations can get screwed up because you might be adding something over here and it will take this and add it first before it multiplies. I mean, you've got to think about order of operations. That's why the scientific notation button is so important, because it tells the calculator that it's one measurement, not two measurements being multiplied. And that's what this is. It's two measurements being multiplied, and we don't want that. All right, so now that you know, I will leave it to you to try doing these on your own calculator. The answers will be in, well, let me go ahead and put the answers down for you really quickly so that you will know what they are. If you have trouble coming up with them, you need to let me know. Well, I'll tell you what if I just do one with you, okay? Look at this. That one's not as easy to see as this one. Let's do this one. It's easier for everybody to see, okay? So let's do this one. Look at this. We're going to say 5.5 scientific notation button. There's the E. And then the negative 2 for the power. Now that's one measurement. It knows that. And we're going to add this second measurement. So plus, and then put in the coefficient, 9.8. Tell the calculator this is a scientific notation value. So there comes the times 10. And then you tell it the power on the 10. So now I have two measurements being added together, not four. Okay? So we hit the equal sign and we get 0.648. Now, that is the answer, but it's not in proper scientific notation form. Here's another little trick. If you have an answer and you want to put it in proper scientific notation form, you don't actually necessarily have to do it yourself. You can tell your calculator to do it. somewhere on your calculator there's going to be a mode or a button, SCI. That will do it for you. So look at this. Notice SCI is the second function of this button. So I'm going to hit second and hit that. Now, we want to know, do we want a floating decimal, engineering, or scientific notation? You go over, you hit that. Oh, look, there is the exact same answer. And now it's 6.48 times 10 to the negative 2. Isn't that cool? Now, let's see. If you're using a graphing calculator, you actually have to go into, let's see, where is it? Mode. Here we go. We have to go into mode, and you have to come down here. Oh, no, it's right at the top. Normal or expanded form, scientific notation, engineering. So you want scientific notation. Okay, so now if I stick in a really big number and then just hit enter, it puts it in scientific notation for me because you've told it you want your answers in scientific notation form. If you don't want the answer in scientific notation form, go back to mode, take the cursor, put it back on normal and hit enter. Hit enter again, and it, oh, nope. Oh, I don't think it'll give it back to me because it's, well, I don't know why it won't give it back to me, but it should. Yeah, because it's on normal now. I think it's because we already converted it. But in any case, it would have been right there anyway. Okay. So, that's how you can use your calculator with scientific notation. Please do not use the caret for scientific notation. Do not use times 1, 0, caret, power. Don't do that. Get used to using the scientific notation button. Oh, I almost forgot. What was the number on that? Okay, so the answer for this one was 6.48 times 10 to the negative 2. All right, real quickly, I'm going to stick in these others. Okay, so this one you should get 8.125 times 10 to the 9th power. You do them with me so that way you can see if you're getting them right or not. Okay? All right, now over here we've got a simple 55, and we're going to say times 1.6 e negative 19. Okay, and we get 8.8 times 10 to the negative 19, okay, because this is your value in scientific notation. All right. Oh, there's one more. Let's see, 1.1 times 10, or e to the 22, minus 9.8 e to the 21. And we get 1.2 times 10 to the 21st power. Okay, so check those out. Now, if you're not getting these, make sure you want to message me about what your problem is, and we'll take a look at it. The last thing I want to look at was scientific notation. And yeah, I know it seems like it's been a lot, but really if you think about it, it's not been that much. It just takes some time to get through it. What if you have a number in scientific notation and you want to go back to expanded form? Well, what you have to remember is that in expanded form, the power of 10 is 0. So it's saying you want to go back to a power of 10 to the 0 so that you can drop it, because 10 to the 0 is just 1, and any number times 1 is itself. So if you need to add to the power of 10 to get a 0, then you're going to move the decimal to the left. How about that? So look right here. We've got 3.5 times 10 to the negative 5. To make the negative 5 into 10 to the 0, you'd want to add 5. Negative 5 plus 5 is 0. All right, negative 5 plus 5. But if you're going to add 5, you're going to move the decimal to the left. 1, 2, 3, 4, 5 places. So 3.5 times 10 to the negative 5 would simply become, because 10 to the 0 is just 1, you can drop that, and you get 0.000035. Okay? If you need to subtract from the power of 10 to get 0, then you would need to move the decimal to the right to expand it properly. All right? So if you have 4.84 times 10 to the 4th, in order to make the 4 a 0, you have to subtract 4. And if you're going to subtract 4, you're going to take that decimal and move it 4 places to the right. Okay? So we're still using left and add together. We're still using subtract and right together. Okay? Same two words go together each time. So look right here. If you have 1.5 times 10 to the negative 3 and you want to expand it, you want to add 3 to the negative 3 to get 0. But if you add 3, you're going to move the decimal left. So that would be 0.0015. And we've moved the decimal 1, 2, 3 places. See? Okay, let's do a different one. 6.7 times 10 squared. We would have to subtract 2 to make that 10 to the 0 and drop it. But if we subtract 2, we have to move the decimal 2 places to the right, which would make it 670. Okay? Back over here. Negative 6, we would have to add 6. And if we add 6, we're going to move the decimal to the left 6 places. So 1 for the 3 and 5 zeros. So 1, 2, 3, 4, 5, and then the 3, and then the 4, 5. Okay? Over here, we need to subtract 5. But if we subtract 5, we got to move the decimal to the right 5 places. So that'd be 1, 2, 3, 4, 5. All right? Over here, we need to subtract 4 to make that 10 to the 0. And if we subtract 4, we got to move the decimal 4 places left. So there'd be 1 place for the 5 and then 3 zeros. 1, 2, 3, 4. And then add the 2 and the 3 on there, because we can't drop them. All right, so far so good. The last one. You're subtracting 5, so you have to, add 5. That makes that drop out to, because 10 to the 0 is just 1. And now if we've added 5, we've got to move the decimal 5 places to the right. So there's our first, right? 1, 2, 3, 4, 5. There we go. If you want to put in some commas, so you get 92,200,000 for that. Okay, so I hope this helps, and I hope you will practice the accompanying assignment for practice to see how you do. And if you're having any trouble, please let me know, and we'll take a look at it. Thank you.